Okay, so here's what we got. So we're talking about right triangle trigonometry. The fact that we're working with right angles is a very big deal. You got to have that right angle in there in order to do right triangle trig. So for this first one, Pythagorean theorem, legs squared plus legs squared equals hypotenuse squared. We got x squared plus y squared equals z squared. And then the word adjacent means next to. So you're adjacent to your neighbor, you're right next to them. Now, if we were talking in as far as position goes, Mr. Saxton sets up his room where everybody's looking at each other, right? So there is a person opposite from you in your position in the room, right? So you are across from each other, okay? So when we say the word opposite, what we mean here is we mean across from, okay? Or you can just say across.
Across two.
Yeah, sure. Okay? So right here I've got the word trigonometric ratios. Now we call them often trig ratios or we call them trig functions. We kind of use those interchangeably, and here's what they are. They are created using the sides of a right triangle. They're the ratios created by the sides of a right triangle. And once we decide which angle we're going to work with, so we always choose one of the acute ones because we know that we've got a right angle in each one of these, then we name the sides with respect to that angle. So with respect to that angle, whatever that acute angle is. No matter which angle we choose to work with, whether we choose to work with, let me slide this down here, the one up here or the one down here, there is one name that we do not have a choice over. And that's because it's a right triangle. There's one side, what is it called? The hypotenuse. So would you write HYP right here? That's how we're going to abbreviate it, and I'll spell it out once. HYP, hypotenuse. That's how we spell hypotenuse. We're going to abbreviate that as HYP. We're going to abbreviate adjacent with ADJ, and we're going to abbreviate opposite with OPP. So if we're working with this angle right here, I'm going to highlight it, then we can name the other legs. Listen up. We only have a choice about the name for the legs because we're working with that angle. So this is the hypotenuse. The one right next to it, that is the adjacent side. And the one across from that angle, the side created by that angle, that's the opposite side right here. Okay? Now, there are three trig functions. You've seen these for years on almost any calculator that you've used. Most people, especially if they're younger, they say sin, cos, and tan. Okay, we don't say that. If you say that, it just kind of shows a little bit of ignorance. Now, there are people that say that, and that's totally fine. So, they're called sine. This is how we spell the whole word. This is how we spell cosine. And this is how we spell tangent. Okay, no surprise really on any of those, but we do abbreviations. So, this is the sine of theta, the sine of that particular angle. So, the sine of theta is these two sides related to each other. So, the sine of theta is the opposite, so write OPP, over the hypotenuse. The cosine is the adjacent over the hypotenuse. And then the tangent is the opposite over the adjacent. Now, this is by convention, this is historically speaking, this is what they came up with when they were figuring out the ratios of sides of right triangles and stuff like that. These are the names and these are the ratios that we use. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So then the question, Samara, is, my gosh, how do I remember all this crap? Okay? So, this is a mnemonic device. This is how you spell it. A memory device. This is a tool that you can use. Now, a lot of people learn this. I did not learn this, and I never really liked it. So, SOH is the first word. CAH is the second word. And the last word is TOA. So they say the phrase SOHCAHTOA. If you hear somebody say SOHCAHTOA, and this is a very common thing, what they're talking about is they're talking about the three main trigonometric ratios. So how does it work? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, I was never a huge fan of that because I wasn't a great speller, and I could never remember, how do you spell SOHCAHTOA? Because I would think S-O-C-A or K-A or something like that. So if you like that one, this one's totally okay. The one I learned was this. Oscar had a hold on, Arthur, or you can say Alice, or whatever you want. So the thing I like about this is it's a phrase. You don't have to remember how to spell it. All you have to know is what's the first letter of each word. So the first letter of each word is OH, AH, OA. And the reason you don't need the S and the C and the T is because if you look at your calculator right now, or if you ask anybody what are the trig functions, they will always say them in this order. They will say sine, cosine, and tangent. So the sine is the opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. I don't care how you remember the three main trig ratios, but you've got to have them memorized. You have to know what they are. So remember SOHCAHTOA, or Oscar had a hold on Arthur, or make up your own phrase, but you've got to know what they are. Okay, everybody good there? Thank you very much. Okay, there are also three, write this word down, reciprocal. There are three reciprocal trig functions, or reciprocal trig ratios. And their names are cosecant, secant, and cotangent. And again, same triangle, same angle. We're using theta in this case. And this is what cosecant is. So you'll notice the abbreviation, a little more funky than the other one. This is cosecant, and it is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over the opposite. Yeah, hold on. But if you remember the first three, my argument would be that all you need to know is remember the order here. And do you see why they're called reciprocal trig ratios? Why are they called that, Samara?
Because it's just the other one, which is small.
Yeah. I'm going to write recip of sine of theta. The secant is the reciprocal of cosine of theta. And the cotangent is the reciprocal of tangent of theta. Okay? And that's how they work, and that's how you can get them straight. Now, I will tell you this. We're not going, and I have this at the bottom of the page, so we'll talk about it again. We don't use the reciprocal trig functions very much. They're kind of complicated. We'll use them a little bit in this class. You'll use them more in the future. Okay? But it is good to kind of know what they are. Now, here's the way I remember this. Cotangent, piece of cake. It's just the reciprocal of tangent. It's got it in the name. Nobody likes cosecant. Okay? If I were to choose, I kind of like this because it sounds a little better. And when I was a kid, I came up with this. This is the way I've remembered it since I learned this 35 years ago or so. I would say not secant. I would say in my head, I would say sec cosine. Sec cosine. Because it's got the letter here. It's the reciprocal of cosine. So in my head, I just came up with this device that said, hey, if I say secant, in my head I'm going to say sec cosine, because it's the reciprocal of cosine. Cotangent, easy. Sec cosine, it's related to cosine. And then the other one's got to be related to sine. Now again, we're not going to use the reciprocal trig ratios very much, but we are going to use them a little bit. So we slide down here to the bottom of the page. Here's an angle. Once you have an angle, you do not have a choice about what we call these. If we're working with this angle, the one across from it is the opposite. The one next to it is the adjacent. And no matter what angle you choose, this one is always the hypotenuse because it's across from the right angle. So the sine of theta is the opposite over the hypotenuse. We will. The cosine is the adjacent over hypotenuse. The tangent is the opposite over the adjacent, so that's going to be 8 over 15. What's the cosecant going to be? 17 over 8. Secant, related to cosine. See how I said secosine? 17 over 15. Cotangent, 15 over 8. Done. You have some problems on your assignment that are just like this. Mason.
Wouldn't we be able to like plug it in backwards?
We're gonna get there. We're gonna get there. Just chill out. Just chill out. Okay. All right. Take a look at the next one. Okay. There's something wrong with this one. Now we're using this angle right here. So this is the opposite side. This is the hypotenuse. And this right here would be the adjacent side, but we don't know what the adjacent side is. So crew, how do we find it?
you do 8 squared plus that one side squared.
We'll call it x.
X squared equals
Square root
12
of 80.
squared.
What is it?
12 squared.
12 squared. Okay? So this is 64, whoops, plus x squared. This is 144. And what did you say it was?
Square root of 80.
Yeah, if you subtract 64, you get an 80 right here. So we're going to take the square root of both sides. Please don't give up on this. Don't say anything. How would we write it in simplified radical form? D?
4 radical 5.
It is, because this is 16 times 5, so this is going to end up being 4 radical 5. So 4 radical 5 here. So I'm going to erase the x, and I'm going to write this down as 4 radical 5. Now pay close attention to this because this is going to get kind of interesting, and this is easy. Here's all I want to do. Opposite, careful, opposite is the one across from the angle that we're interested in. So this is 8 over 12. Let's reduce it to 2/3. So make sure you simplify, and it says rationalize the denominator if you need to. Cosine. Cosine would be the adjacent. Notice it's next to the angle that we're working with. So that's 4 radical 5 over 12. And yeah, I'm going to simplify that too. So this is going to be radical 5 over 3. The tangent is kind of interesting because it's the opposite. That's this one over here, because again, we're working with theta up here. So that's going to be 8 over 4 radical 5. Now, I'm going to zoom in on this one for just a second. And I want everybody to watch because this happens a whole bunch when we're working with trig functions. What do you do with that? D?
Multiply radical 5 to the top and bottom.
Very good. Okay, the first thing I'm going to do is I'm going to simplify this. This is going to be 2 over radical 5. Is everybody okay with that?
Yeah.
Okay, I'm going to change colors on this right here because I'm going to do what D said. Now, D said multiply the bottom by radical 5 and the top by radical 5. Do you remember what that's called? There's a name for this. It is a funny looking one. Yeah.
Oh, I don't know the name.
What's it called?
Rationalizing.
Rationalizing the denominator. So here's what happens. I get 2 radical 5 on the top, and I get a 5 on the bottom, and I put a box around that because that's the final answer. That's called rationalizing the denominator. Everybody good there? Okay, let's do these guys. This is cosecant of theta. So that's going to be, wait, that's the hypotenuse over the opposite. That's going to be 12 over 8. Isn't that just going to be this one flipped over?
Yeah.
Okay, so is everybody okay if I write 3/2?
I guess.
Secant?
You're gonna have to do the weird method.
Mm-hmm. So we're going to multiply by radical 5 on the top and bottom, and I get 3 radical 5 over 5. And there, I'm in good shape with that. I'm going to put a box around each one of these so we know what the answers are. Okay, watch. If I flip this one over, I could do it that way, but take a look at this guy right here. What if I just flip that over?
Then it's okay.
Then I have radical 5 over 2, and I would be done right there. Everybody got that?
Yes.
Okay, watch. Don't write this down. Watch. I'm going to take this one. I'm going to say, hey, the cotangent is the reciprocal of tangent, so I'm going to do 5 on the top and 2 radical 5 on the bottom. And I'm going to rationalize. These two will turn into a 5, so this is 5 radical 5 over 2 times 5. And don't the 5's cancel? End up with a radical 5 on the top and 2 on the bottom? We good? Okay, all right, flip the page over. Like I said before, we don't spend a ton of time on reciprocal trig functions. Okay, I'm going to read this really slow because this is a really key idea. Will you pull the door shut? Thanks. We now know how to find the ratio of sides when given an angle. We now know how to find the ratio of sides when given an angle. So here's a key point in trigonometry. Trig functions take angles and give ratios. So you put an angle into a trig function, and it will tell you what the ratio is. So like most operations in math, there's a way to undo it. You learn how to add, you learn how to subtract. You learn how to multiply, you learn how to divide. You learn how to square things, you learn how to take a square root. So trig functions also have inverse trig functions, and they look like this. So this is called sine inverse. I usually say sine inverse. Cosine inverse. This is tangent inverse. And you'll notice it looks like each one of those is an exponent of -1. Would you write a big capital NOT there? Those are not exponents. If you put a -1 on a function, it's the way the mathematicians decided, hey, if we want the inverse of something, we're going to put a -1 and it'll look like an exponent. Yeah.
Don't people sometimes use arcsine or?
They do, thank you very much. I actually had a calculator when I was in high school that had the arc button on it, and I didn't know what it did. I had to ask my teacher what it did. And if you see an arc on a calculator, which you probably will never see again, okay? If you're digging up some old stuff, maybe you do. But yeah, you could say arc sine or arc cosine. Good point. Okay, anything else? Okay, so here's what we're going to do. In order to use inverse trig functions, so that we can kind of make sense of what's going on, we need to have our calculator in degree mode. So grab your calculator, hit the mode button. So I'm going to pull this up. And if you haven't reset it lately, you probably ought to. Come down to the third row. Notice that the default is radians. The people at TI and the people that make calculators know that radians are the best thing to use, but we're going to use degrees. So I'm going to hit enter. Then I'm going to hit second quit. I'm going to go back to the home screen. Okay, so since trig functions take angles and give us ratios in return, inverse trig functions do the exact opposite. They take the ratios and they give angles. So write the word angles right here. So I'm going to zoom in on this. And here's what's going on this one. It wants us to find, watch, sine inverse of 0.5. So in other words, it's asking us to solve an equation like this. It's asking us to find an angle whose sine ratio is 0.5. So I want you to watch. If I do the sine inverse of both sides, that was an equation, right? I put a trig function into an angle into a trig function, okay? And then I'm going to do the sine inverse of that. What do these two things, what does sine inverse do to sine? It's kind of like asking this question. What do those do to each other? They cancel each other out. So we just get theta on this side and we get sine inverse of 0.5. So grab your calculator. We're going to type in sine inverse. Notice it's the second function. Sine inverse of 0.5. Hit enter. 30 degrees. Remember, we put it in degree mode, so we have to know that our answer is 30 degrees. So just write 30 right there, put a degree on it, and we're all set. Okay, look at the next two. Before you do either one of these, I need you to look up here really quickly, because once you know how to type it in your calculator, it just spits out an answer. That is a ratio. It's a ratio of the opposite side over the adjacent side. So if you were to draw a triangle for this, and this is theta, the opposite side is 6 and the adjacent side is 1. My question for you is, before we have the calculator spit out an answer, is theta going to be a small angle or is it going to be a pretty big angle? D? Relatively big. Why do you say that? Oh, because you put it in your calculator already? Take a look at this. If the opposite side is bigger than the adjacent side, wouldn't this have to be a pretty big angle to have that opposite side be big? Okay, let's type it in. Tangent inverse of 6. You don't have to close the parentheses. You can if you want. Pretty darn big angle. We're going to round to the nearest hundredth. We're not going to truncate. So this is going to be 80.54 degrees. Okay. Would you find the cosine inverse of 0.86? Write it down. Do not say anything out loud. Comfy? We're slamming our calculator down when we get done? Okay, did you get 30.68? 30.68 what? We're in degree mode, so if it gives us an angle, that's going to be in degrees. Okay, so here's what I want you to take a look at. Right here, there are some people that say it in reverse order. If somebody says inverse sine or inverse cosine, you hear them both, okay? So either one is totally okay. If we come down to the bottom here, there's a note, and I want you to read that note. So, as with most operations, undoing something, like the inverse of something, is more complicated than the original operation. Inverse trig functions are far more complicated than regular trig functions. Plugging in an angle and getting a ratio, easy. Taking a ratio and going backwards and finding the angle, much, much more complicated than we're making it look right now. But we can deal with the complications in another course. We can do what we're talking about in this course, okay? So they'll deal with the complications later. We're going to go with the simple stuff. Hope that's okay with you. Yeah.
When's later?
Next year in 3H. Okay? All right, take a look. This one says write one for sine, cosine, and tangent that can be used to find theta. So here's what I'm going to do. Theta's right here. Opposite, adjacent, hypotenuse. So the sine of theta would be opposite sides 3, hypotenuse is 5. Cosine, 4 over 5. Tangent.
Oh, okay.
Got it? TOA, or on Arthur, 3 over 4. So if I take the inverse sine of both sides, or sine inverse, this is going to be theta equals the sine inverse of 3/5. Let's do the next one. This is going to be theta equals the cosine inverse of 4/5. And this one's going to be theta equals the tangent inverse of 3/4. Now, do not do anything else. I want you to think for just a second. You ready? Still see a little writing? Okay, take a look. This is an inverse trig function. What are we plugging into it? A ratio. What's it going to give us in return? It's going to tell us what the angle is. So grab your calculator, okay, and let's do this. Would you guys do the sine inverse of 3/5? Would you guys do the cosine inverse of 4/5? Would you guys do the tangent inverse of 3/4?
I did all of them.
You did all of them?
Yes.
Wow, that's a cool one.
What'd you get?
36.87.
You did 3/5?
Yeah.
36 point what?
87.
36.87 degrees, right?
Yes.
What'd you guys get when you did cosine inverse?
36.87.
You got theta equals 36.87. Tangent inverse?
Same thing.
Same thing. Okay, so 36.87. Got the same thing either way. Now, on this one, take a good look here. I'll skip ahead and I'll give you an answer. We're missing something right here. This actually ends up being, if you turn this into legs squared plus legs squared equals hypotenuse squared, this ends up being the square root of 88. And the square root of 88 is 2 radical 22. Now, do we have to simplify it?
Not really.
Could you use the square root of 88 if you wanted to?
Yeah.
Okay, take a look at the sides. Here's what we've got. I'm going to change colors here. Opposite, adjacent, hypotenuse. Sine would be 9 over 13. Cosine would be?
222.
I'm going to write radical 88 over 13, because I don't care if we simplify, because that's not going to be the final answer. And then the tangent is opposite over the adjacent. Whoops, radical 88. So how do I find theta in each one of these cases?
Wait, do you have to do the thingy?
Rationalize?
Yeah.
No, here's the cool part about this. Because theta will equal the sine inverse of 13 over 9. Oh, sorry, 9 over 13, I apologize. 9 over 13. theta on this one will be cosine inverse of radical 88 over 13. And then tangent inverse will give us theta also, and it's the tangent inverse of 9 over radical 88. So would you throw all of those in your, same ones, would you guys do sine? You guys do cosine, and you guys do tangent. Check with your neighbors. Okay, Gavin, what'd you get when you did sine inverse of 9/13? 43.81? Is that right? 43.81. Samara, what'd you get when you did the cosine inverse of radical 88 over 13? 43.81. And I'm assuming you guys got the same thing, 43.81?
Yeah.
Okay, now, we won't make you do that all the time where you have to write down all three of them, but it should be kind of interesting that regardless of the tangent ratio, or the trig ratio that you use, you get exactly the same angle. Mason, real quick.
When you think about it, tangent is just giving you the slope
It
based
is.
on the angle.
It is. You're exactly right. Good point. Good point. Okay. So to do these last ones, these are each one separate thing apiece. It's sine, cosine, or tangent. You don't have to do all three, but there is something missing here.
What?
Can we do trig on these?
No, I don't think so.
Why not?
Because we have to have two sides.
We don't
No,
have to have
no
two sides.
theta.
Yeah. There's no, I heard it,
Theta.
there's no right angle.
Oh, or that.
Okay, now, we put that there for a reason. We're doing right triangle trigonometry. We need a right angle in order to work on these. So it's got to be a right triangle. So for this one right here, if we're working with this angle right here, this is called the hypotenuse. No choice about that. Jack, what's this one called?
Adjacent.
That's called the adjacent. Next question. What trig function involves the hypotenuse and the adjacent? Not a reciprocal one. Let's not use those.
The cosine.
The cosine. Very good. So the cosine of 30 degrees would be equal to the adjacent, which is x, over the hypotenuse, which is 8. So Sai, if I were going to solve this equation for x, what would we do?
The cosine over.
No, I want to get the x by itself.
Oh, yeah.
Multiply by 8. So we're going to multiply this side by 8, and we're going to multiply that side by 8. So we're going to get x equals, grab your calculator,
What?
8 times the cosine of 30. So I'm going to clear this off. 8 cosine of 30 degrees. I type that in the calculator, and it says 6.93. Circle that, we're done.
Why when you press? Oh wait. Never mind.
Good. Mason, can you tell us what the name of this side is?
Okay, that'd be the adjacent.
It is the adjacent. And what's this side called?
That would be the opposite.
Very good. Okay. Andy, can you tell us what trig ratio or trig function relates the adjacent and the opposite? Tangent. So the tangent of 45 degrees is equal to the opposite, which is 10, divided by the adjacent, which is x. Now this is a little more complicated. There's a couple different ways you can solve this. Here's what I'd like you to do right now. Type into your calculator tangent 45. Let's figure out what number that is. It'll tell us what that ratio is. It's 1, right? So 1 equals 10 over x. And then, how do I get that x up where I can work with it? Yeah, times both sides by x, so I get x equals 10. So there's the answer. And then would you take a look at this triangle for just 1 second? What type of triangle is this? 45, 45, 90. Shouldn't the legs be the same length? And did it work out with trig? It did. Would it work out with our knowledge of special right triangles and stuff like that? Everybody good? Last one. Would you name these sides according to where this angle is? And would you set up a ratio for that one? That's an opposite, isn't it? And hypotenuse? Angela, what trig function relates the opposite and the hypotenuse? SOH. So it's the sine. So the sine of x would be equal to the opposite, 200, over the hypotenuse, 230.94. So how do I figure out what x is? Zach?
You multiply both sides by sine -1.
Kind of. We take the sine inverse of both sides. That's the way we say it. So we're going to take the sine inverse of this side, and we're going to take the sine inverse of this side. So type this into your calculator. We're going to do sine inverse of, and go ahead and type in 200 divided by 230.94.
It's like not exactly. But
Doesn't have to be exact. Is it pretty close? What is it? About 60? Rounded to the nearest hundredth, is it 60?
We used to do these things like circles.
Okay. What'd you get? 60?
60.000462.7.
Yep, 60 degrees. We'll call it that. Now, I have your assignment here. I want you to do the whole thing. You'll notice that it just has you write down the 6 trig functions here, and then on the back side, take a look at the instructions. Sine, cosine, or tangent. Sometimes Sometimes you're going to be finding a ratio. Sometimes you're going to be finding an angle. And then the last thing is this. If you're wondering what they used to do before they had calculators, and I actually did this, this is called a trig table. Okay? You would have to look for each number. They're rounded to the nearest thousandth, and I want to take a look at the last row. Okay, 45 degrees. There's the ratio for sine. There's the ratio for cosine. There's the ratio for tangent. Didn't we just figure out on our calculator the ratio for tangent is 1? There it is on a trig table. So, if you think you have it bad coming up with all this, imagine having to use one of those. Okay? We'll talk more about that tomorrow. Have the assignment done. The more you have done, the better off you're going to be tomorrow.